When is an identical value not an identical value? Well, when a calculation goes wrong, it's usually because of a faulty formula, so you spend time trying to correct it. But unbeknownst to you, sometimes the problem actually lies with your data. Let's look at 3 examples of this. We have 2 numbers that look identical, 2 text values that look identical, and 2 more text values that look identical. All of these values use the general number format. But when we do an equality test, they return false. Why can that be? Let's start with the first example. There are 3 quick checks I like to do that cover most scenarios. One is to find the character length of the values. Simply reference the range inside the len function for that, and you can see that both are 5 characters long. That's not an issue then. So let's test whether these values are actually stored as numbers. Use isNumber for that. And this time it returns true for the top value and false for the bottom. Why can that be? Well, let's also check for text using isText. Now that confirms our suspicions. The top value is correctly stored as a number, whereas the bottom one is stored as text. This often happens if you've imported or pasted data from an external source, but it's very easy to fix. You can flush the cell by reconfirming the value. That will make it a number, so now both tests return the same results and are equal to true. In the second example, I've performed the same tests, and just look at the interesting results. The length of the second one is returning a value error. Neither is a number, as you'd expect, but the second one isn't even considered as text. Why is that? Well, if I click on each cell, they've displayed differently in the formula bar. The first is a regular text value, and the second is a data type. Up until recently, data types were obvious because they displayed a little icon next to them, and they still do, but only if you have the data type icons checkbox ticked on the View tab. This is a relatively new feature, but having it off can cause confusion if you're not careful, as you just saw. You can convert the text value into a data type by going to the Data tab and selecting the appropriate one. There are only 3 these days, so if your data doesn't fall into one of these categories, don't bother. Or, if you want to convert the data type into a text value, right-click on the cell, hover over Data Type, and choose Convert to Text. The final example is the trickiest. I've already done the length test, the number test, and the text test. All are the same. So we'll move on to the Unicode test, which will give us the unique number of a character. As all the letters look the same here, we'll target the space, as there are over 20 types of spaces in Unicode. To do that, start with the Unicode function, and then nest mid inside it. There, reference the range in the first argument. In the second, put 7 because the space is the 7th character, and a 1 in the last because we only want a single character extracted. Close up and confirm the formula. And we've discovered there is a difference. The space in the first value has the Unicode character 32, whereas the second is a non-breaking space with a value of 160. 32 represents a standard space on your keyboard, so you can easily change the other by deleting the existing space and then pressing the space bar. Now everything is equal, so there we go. Admittedly, for these examples, I didn't have Excel's error checking feature turned on. If you go to File, Options, Formulas, this checkbox will be turned on by default. It's flagged this cell because it's detected a number stored as text. And it's flagged this one because it's detected a formula error. But it hasn't flagged either of the 2 values in examples 2 and 3. So while it's good to have it turned on, don't depend on it because it's not 100% reliable.